Okay. Cyclic geometry. It's very simple. This thing is very simple. Say you have a cycle like this, ne? My cycle is very cute. Dog is very cute. Okay, cool. So you have a cycle and there's a line. We say that line was AP, ne? The line was AP. And you have a center. That center was O. My handwriting. That center was O, right? They are saying if you have a line drawn from that center, my handwriting. Okay, cool. If you have a line drawn from that center and that line is perpendicular to this chord, because this line is called a chord. Therefore, this line bisects this chord. Therefore, what does it mean? This guy is equal to this guy. Ne? That's all it's saying. You know what I'm saying? That's the theorem. If this line is drawn from the center and it's perpendicular to this chord, therefore these two segments are equal. Which means, let's say you have a C here, ne, or something, ne? Therefore AC is equal to what? BC, ne? Something like that. Ne? That's what it's saying. Simple as that. Okay. Now let's say you just had a line like this, and they said this guy is equal to this guy. Say you had a C here. If this AC is equal to BC or CB, therefore this line is perpendicular to this line, right? That's what it's saying. A line drawn from the center to the chord, perpendicular to the chord, bisects the chord. Or if that line drawn from the center bisects the chord, therefore that line is perpendicular to the chord. You know, it's just that. And also, they can phrase it this way. They can also phrase it this way. Okay, let me erase this maybe. They can also phrase it this way. They can also phrase it this way. There are many ways they can phrase this thing. Say you have maybe point J here, right? And there is a line from point J all the way to this chord. And they tell you that this line is perpendicular to the chord and it bisects this chord. Surely this line has to pass through the center somewhere. So they're saying a line from anywhere in a cycle, and it's literally if the line is perpendicular to the chord and bisects the chord, therefore that line passes through the center. I mean, it's just simple as this, that, simple as that, simple as that, simple as that. You know what I'm saying? And also, okay, maybe let's move on to other theorems that are a bit, you know, a bit. But these things are very simple, very simple. Say you have now A, B, and you have maybe like C and D here, right? So now there's this all the way here and this all the way here, right? Something like this. Let's say this was, his angle is C, ne? They're saying this angle is equal to this angle. Why? Because they are subtended by the same what? They are subtended by the same arc. This guy over here is called an arc. Same arc, AP. Or even if there was a line here, this angle is still going to be equal because they are subtended by the same chord. That's it. Simple as that. Same applies to A and B. These guys over here, they're equal because they are subtended by the same arc, CD. Or if there was a line here, they were going to be subtended by the same chord, what? CD. Simple stuff. Okay. Another one. Say now you had something like this. Maybe you had let's say a cycle again. You literally have a center and you have a line like this, ne? And then you have an angle here. Maybe let's say this was C, this was A, this was B, ne? And we have this guy over here, right? Maybe this was O, right? You see this is 180 degrees, right? Because this is a diameter. Surely this should be 90 degrees. Why? Because they're saying angle at the center is 2 times angle at the circumference. Or in this instance, you'll be like angle subtended by the diameter is equal to 90 degrees. Maybe the better way to introduce this is by touching on this first, no? You just touch on this. You'll be like, if I have a circle like this, and I have this center, and I have an angle, something like this, no? Maybe this is my angle O, this is my O1, and this is my O2, right? And let's say this was C, this was A, this was B, ne? O2 is equal to 2 times angle ACB, ne? A angle CB, right? So more like this angle, right? It's 2 times that angle. Why? Because angle at the center is twice what? Angle at the circumference. So simple as that. And with that logic in mind, you can therefore say you had something like this now. Say it's something like this now. Let's just erase this. Okay, let's erase this again. Let's erase this again. Let's erase this again. Say now you had something like this. A diameter, as I said. Say this is a center. And there's this angle, the circumference. Knowing that this is what 180 degrees. Therefore, this should be half of that, and that's 90 degrees. And then they say angle in a semicircle, angle in a, angle in a semicircle, angle in a semicircle, circle. I mean, there are many reasons that you can say here. You can also say angle at the center is twice angle at the circumference. Yeah, something like that. Okay, cool. And then another theorem would come and say, these things are very simple. They are very simple. Say now you have a circle like this. Or maybe let's stick to black. Black is beautiful. So you have a circle like this, and then you have something like this, right? Okay, this is within the circle. This is within the circle. This is within the circle. All the points should be within the circle, right? Another rule says, let's say this was A, B, C, D, right? They're saying opposite angles. So angle A plus angle D, right? Plus angle D should be equal to 180 degrees. Why? Because these are opposite angles of what? Of a cyclic quad, ne? Cyclic quadrilateral, ne? The same applies with angle what? Angle CB. If you add these angles, they should give you what? 180 degrees, right? And then say you were to extend a line here. You know that angles on a straight line, they're also supplementary. So since these angles, like this angle plus this angle, if you add them, they give you 180. Also, this plus this, if you add this, they give you 180. That means this angle is equal to this angle. You know what I'm saying? So that means angle A is equal to this angle. And they say it's an exterior angle of a cyclic quad, but it's derived from the fact that opposite angles of a cyclic quad, they add up to 180. If angle A plus angle D, let's say this is D1 or something, give you 180. Therefore, D2 is equal to angle A, because when you add angle D1 and D2, they also give you 180. Simple logic, right? Simple logic. This thing is very simple. Very. It's super simple. Super simple. This is where you should just score 100% straight. And also, one theorem can say this. Say you have a line drawn at the center, like a radius, right? A radius. And you have maybe a tangent here. A tangent is always perpendicular to the radius. That's standard. Every time when there's a tangent, when a tangent meets the radius, they form 90 degrees. Even if the tangent was passing here and there's a radius, they will surely form 90 degrees. That's it. That's a theorem. You just need to know that the tangent is always perpendicular to what? To a radius. What else? What else am I missing? Then you might have something like this again. You have maybe a point here, right? A point here. Then you have this line. I want to draw it such that it becomes a tangent. Let me start it from here then. It's a straight line. It's a straight line. Make it straight in your eyes. This is a tangent. Oh my gosh. And this is also a tangent. Eh? Let's say this was A, this was B, this was C. Tangents from the same line, same points are equal. You know what I'm saying? So tangent from A, that means AC is equal to AB because these are tangents from the same point. That's it. That's it. And also maybe something that might also, come up in your exams. They'll be like, if they want to trick you, they can say, I'm just speaking from my head, right? So it's this. And then you have a chord maybe like this. And then you have that chord subtending maybe an angle here, right? It subtends an angle here, right? Maybe it subtends an angle here, right? And then there is a tangent. Then there is a tangent here. At this guy, like this guy, there's a tangent here, right? You see that this is your chord, ne? Okay, let's say this was maybe A, B, C. You see, you can divide A into A1, A2, and A3, right? They're saying the angle between the tangent and the chord is equal to the angle subtended by that chord. What does that mean? Let's make an example with A3, ne? So you have this guy here. Therefore, A3 is between tangent AC is between this tangent, right? It's between this tangent, right? And the chord AC, right? What does chord AC subtend? It subtends this angle B. So therefore A3, let me use a color that's more visible there. Therefore A3 is equal to what? Angle B, ne? Yeah, I'm saying A3 is equal to angle B. What is A1 equal to? A1 is between the tangent and this chord and this chord, right? What does this chord subtend? It subtends this angle, right? So therefore A1 is equal to C. Why? Tan chord theorem. Angle between the tangent and the chord is equal to the angle subtended by that chord. You know what I'm saying? That's it. Then they can trick you if they want to. But I mean, these things are very, 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 very simple. They are super simple. Super, super simple. Maybe they can trick you and say, prove that this is a cyclic quad, something like that. They just give you this. And then they say, prove this is a cyclic quad. Maybe this is A, this is B, this is C, this is maybe D. How are you going to prove that? If you have this angle and this angle, or you have this angle and this angle, just add these two angles. If they give you an 80, then this is a cyclic quad. Or add these two angles. If they give you an 80, this is a cyclic quad. You get what I'm saying? Simple, 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 simple. Or maybe you can also do something like this, ne? If you want to be fancy, right? You can just draw this, like something like this. That's if you want to be fancy, something like this, right? And also draw something like this, ne? If these two angles are equal, therefore this is a cyclic quad because they'll be subtended by the same chord DC. I mean, this thing is very, very simple. So it will be a matter of practicing. But those are just basic concepts of this thing. Maybe when we meet again, we'll just play around practicing.
Subscribe, comment, like, and share our videos.